Well, this came in the mail today. This is a TRS-80 Model 4 microcomputer. Yeah, you can see that this very obviously shares the case with the DT-1. I mean, they're exactly the same. So, that's kind of cool. This one's broken. We'll fix it in some other videos after we're done with some other stuff. Let's very quickly look at that board out of that DT-1 and talk about it some. Yeah. Alright, so here is the board. There's a lot of discrete logic on the board. As you can see, there are a lot of 74 series gates all over the place. That's what most of the smaller chips are. This chip right here is a 64-bit RAM, I think. I'm not sure what it's for, because these are 4 RAM chips here, which I assume is the display memory, but I wouldn't swear to it. This is the video generation chip down here. That's a 8276 video generator chip, and then this is the character ROM here that had the window uncovered. So since we can see characters on the screen when we go into setup mode, I think it's safe to assume that this ROM is fine, since the board was upside down and the light couldn't get into that uncovered erase window. I think that most of this, if not all of this, is for the video generation. So the actual CPU part of this serial terminal is run by an 8051 microcontroller. And if you've never done embedded stuff, you may have never heard of the 8051, but it was an extremely, well, is still, derivatives of it are still extremely popular microcontrollers. And this, to my knowledge, is the only Harvard architecture CPU that ever really gained a widespread following, which is what makes this a very interesting CPU, even though I don't particularly like it from a personal standpoint. The Harvard architecture has the code and the data memories completely segregated from each other. It's a holdover from like Babbage's difference engine and old relay computers and the stuff from World War II era. They would the ROM in those machines would be a stack of punch cards that would run through the machine, and it would the only storage it had was registers inside of the CPU. So I guess this that design made its way over into this chip. It's kind of a foreign concept to us these days. All of the machines that we use are Princeton architecture machines, meaning that the instruction and data memory are all lumped together. The advantage of this kind of design is, I guess, it makes it a lot simpler in design, but of course you can't write self-modifying code on these things. You can't even modify the instruction memory in these things. There's a ROM built into these chips that you burn, and that's just what you've got. So yeah, it also has, I think, 128 bytes of RAM on board. The ROM size is either 32 or 64K, I can't remember. That may even vary between variants of the 8051, I'm not sure. And it also has a 2-wire serial port built into it, which is what's driving the host serial port at up to 19.2K. So there's no external UART, there's no shift register magic driving the serial. It's just all coming from this microcontroller. And if it wasn't for the display circuitry on here, this would basically be the serial terminal right here. So that's kind of interesting. This, I think this thing was made in 1980, 1982, something. Well, I think the 8051 came out in 1980, so I'm sure this wasn't made in 1980. Yeah, it's a very, very early adoption of the 8051 in this thing. So very, very simple design, very compact for the day. This will be completely opposite when we examine the Zenith Z19 serial terminal that's coming on the way too. I mean, it if you added a little bit more memory and a disk drive to it, you could probably run CP/M on it and turn it into a general purpose computer. It's got so much stuff in it, like a real CPU and stuff. So yeah, that's the logic board. Nothing to it really. That's the speaker right there, if you were curious, the beeper. And I still haven't looked up the service bulletins on this thing and checked out all of these bodge wires and shit. Hey guys, how's it going? I've been trying to figure out what the deal is with all of these bodge wires on this board out of the DT-1. I did dump the ROM, the character ROM by the way, and posted the dump to a forum to a post in the Vintage Computer forums. So if you run across this video later and you need a character ROM, like say your sticker fell off and your ROM's been erased or something, you can go to the Vintage Computer forums and search that post for a DT-1 character ROM, and you ought to be able to find the stuff that you need to write your own if you have to. Anyway, so I don't know what's going on here. I've double checked my pin count, counting my pins and stuff, and it doesn't make a whole lot of sense to me. You tell me what you think. Alright. Here's what I've found. So if we go and look at this LS138 3-to-8 decoder, okay, this is what's asserting chip select on some of these RAM chips, and sending some shit to select the keyboard, I think, and some other stuff like that, right? But there's this unused pin number 9 on this LS138, okay? And I think this is a typo on the schematic, but you tell me if it's not. I haven't read the data sheets for these RAM chips, so they may require negative 5 volts somehow, but up here it looks like VCC of this LS138 is tied to negative 5 volts instead of positive 5 volts. I don't think that can be right, but I'll have to do some reading or something. Maybe that is right, and maybe this RAM needs negative 5 volt chip select. That's really strange, though. That's just too strange. It's got to be positive 5 volts, because I mean this decoder selects all kinds of different stuff for the microcontroller to read. So it would have to be running off of, you know, proper 5 and 0 volt logic levels. That has to be a typo. It's got to be plus 5 volts up there. So anyway, so this unused, it's the Y6 output, pin number 9 of this LS138 3-to-8 decoder, is bodge wired. Where did the 138 go? Here it is. It's right here. All right. It's bodge wired through. Okay, get this. Oh, I forgot to zoom you out there. Okay, so here's the 138. All right. Now, this is where shit gets weird. Alright, I don't know what's going on here. This bodge wire comes down here and goes through an unused gate on this MC1489 serial down converter. This chip is supposed to take positive and negative 12 volt RS-232 signals and convert them into 0 and 5 volt TTL level signals. Why the output of this LS138 would be going through one of those, like, what? You know, I don't understand what's going on there. Anyway, then the output of that RS-232 down converter gate comes out and goes into pin number 9 of this LS10 3 input NAND gate, and we can see it on the schematic right, oh shush, meter, right here. Alright, so here's pin 9, it just ties onto there, alright, and apparently the output of this gate, wait a minute here, U30 is supposed to be an LS10. I don't know why that says LS9 right there. It's an LS10 on the board. Yeah. So another typo on the schematic, I guess. But it ties right into that bottom input on that 3 input NAND gate. And that line is supposed to come up here. And come out of, or into, well, out of in this case, pin 16 of the microcontroller. So pin 9 of the LS10 is supposed to connect to pin 16 of the microcontroller. So let me get out my beeping contraption, my beeping bastard here. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20, 19, 18, 17, 16. Okay, we're on the right pin of the microcontroller. That's supposed to hook to pin 9. Sorry about that again. That's supposed to hook to pin 9 up here on this LS10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, but I can't read any continuity here, even though the schematic says that there should be. Alright, so I'm not sure what's going on there. Also, these top 2 inputs on this gate are supposed to be tied to plus 5 volts, alright? But there's a trace on, you can see it right here, on the reverse side of the, yeah, there's a trace right here on the reverse side of the board, right beside of this resistor right here. The trace is supposed to be right here. It's been cut, alright, separating this, and this one, this top part is still tied to plus 5 volts, alright. But now, after this trace was cut, okay, this pin 10 that was originally tied straight to plus 5 volts has a 4.7K pull-up on it, connecting it back to plus 5 volts. That's what this silliness right here is. That's the VCC. It's just a 4.7K resistor tied to that pin. So something must be pulling that low. Pin 10 here is connected to the output of an unused inverter. The output of an unused inverter on a 7406, and the input of that inverter comes out of pin 5 of U30, which is down here, alright, which is an input, but it's tied to this right enable line, which is an active low. So when right enable is not asserted, it will try to assert some shit on this 3 input AND gate here, which drives the printer output enable line. What? So, I don't know what's going on. It's all very strange. I don't understand, especially that serial down converter gate. What the hell is going on with that? And there's another weird thing here. Okay, this bodge wire on the back, right next to this resistor. Okay. Focus, you dirty rascal. So, okay, this bodge wire here. All right. It's soldered onto this trace right here that goes straight up to this, the top of, there's a resistor on the other side here. But this, I mean, this trace isn't broken anywhere. So I don't understand the purpose of this bodge wire. I don't know, man. What's going on? I don't know, man. So, I mean, when the board is in the terminal comes on, and you can see a cursor. At least part of the keyboard works. I couldn't make it run the self-test, but that may only be because either the escape key or the V key or both aren't working. You're supposed to hit escape V to put it into self-test mode. So, all of this stuff seems to have something to do with the printer port. And additionally, okay, here is something interesting. U24, right here, okay, you can see that there is a lot of flux residue here. This chip has been replaced at some point, all right? And that's an LS374. But when I look in the parts manifest here, in the service manual, what was that, U24? U24 is supposed to be an LS373. Although it probably doesn't really matter too much. It looks like U24 just latches data onto the printer port. I don't know, man. I guess I'm just going to leave all these bodge wires alone for the moment. And we'll make a serial loopback plug and see if the actual terminal part of the machine works. I mean, I'll never use the printer port on this thing, so I don't really care whether it works or not. And this could have been done by an authorized, like, Tandy service technician too, like at a Radio Shack store somewhere, because I mean, I can't find the technical service bulletins for the DT-1, so this may have been some kind of like recommended repair that Radio Shack did to these things to correct some problem with some design problem, you know. So I don't know, man. But the fact that it goes through this serial down converter chip, that's just really strange. Unless this LS138 really does have a VCC of -5 volts, and that's to do something to change it back to TTL levels somewhere. But it can't. It selects all of the different sub-peripherals in the machine. The keyboard, the RAMs up here, all of that stuff. It can't be running on -5 volts, can it? It's got to be a typo on the schematic. I mean, there are several typos on the schematic. So I don't know, man. I don't know, man. I guess as long as the video terminal part works, we're fine. What do you think? What do you think's going on here? It's very strange, and I'm flummoxed by this mess. What?